Hello grade 11, this is Miss Hughes and this is a quick recap of Sequences and Series Unit 1. First of all, notice the vocabulary. You need to make sure you are confident with all this vocabulary, particularly realizing that for arithmetic sequences we use D as the difference, for geometric sequences we use R as the ratio. And the one thing that gets people confused is also the difference between sequences and series, even though in the test they will most of the time say sum, so you will know that it's a series. A series is when you're adding the terms together, a sequence, you're just listing them. Notice here, for example, you've got 211. At this point, it's not n that's 211. This isn't the 211th term. This term is 211. So at this point, you don't know what n is. You don't know which term number that is. That is something you'd have to investigate. Okay, right. Now, if you go on to It's Learning, there are two useful documents. One is the review. It looks like this. Looks like this. And it's basically a blank version of what I'm about to go through and a blank version of questions that you can do yourself. These are sort of classic questions that come up for sequences and series. And then on the third page, there's some questions about compound interest and general problem solving. So you need to have a go at the examples in your own time, the more practice. The examples here I'm about to go through now. I'm also planning to put the solutions on there. Those are yet to come. Okay, so this is quite a long explanation. There's a lot of examples. If you feel you need to fast forward, please go ahead. So we've got here arithmetic sequences and all the types of questions that you can get. So first of all, the show that questions. Show that means you really have to show that in every case the difference is the same. So, oops, that should be a minus 3 there. Okay, and to get that difference, we always do one term subtract the previous term. Okay? Don't lose any points for laziness. Make sure you show all of those. Then the classic question they could ask you is find un for this arithmetic sequence. So in each case, I've written in red always what do we know to begin with. So we know that u1 is 110 and we know that d is negative 3. In purple, in a box, I've always written down the formula that we're quoting. So this is the formula booklet. Put the ingredients in, 110 and negative 3, and then simplify. Don't forget to simplify, all right? You need to make sure you give the simplified answer. And also, make sure there's brackets here. Without the brackets, this would be n minus 1 subtract 3. With the brackets, it means n minus 1 times negative 3. And they're two different things. All right, moving along. This is another type of question they could ask you where they give you two terms and ask you to find un. I forgot to put on there, I've added it on, assume it's an arithmetic sequence. So again, in red, what we know, u5 and u21. And in purple, the formula. Now, if we use this formula for each of these cases, this is what happens. So using u5, I get that 19, because this is u5 is 19, is equal to u1 plus 4d. This is because u5, so n is 5, and we get 4d. And if I use u21, we get this. This is now a simultaneous equation, and we can solve it by subtracting one from the other. The u's cancel out, and we're left with d equals 6. Now, I ran out of space there, but then you would substitute that 6 back into one of the equations, probably the easiest one, this one. Replace the d with a 6, use that to find u1. Once you have u1 and d, you can build the equation. Okay, next one. Here's where they ask us to find u15 for a specific arithmetic sequence. Now, we worked out earlier that this is the formula for un. Obviously, in the test, you'd have to go through this process and find un. Once you have a formula for un, you can find u15. You could also put y equals and type that formula into your GDC and using the table find the 15th term. That is also okay. All right, moving along. This one now. So this time they're asking, is 41 a member of the sequence? Well, if it is a member of the sequence, then I should be able to find n for it. It should be able to fit into the formula, into this formula for the sequence, for the terms. So I've written 41 equals that. Solve the equation, and yes, we get a whole number. That means that 41 would appear on the list. It would be term number 24. Again, you could use the GDC to show that. All right, this is when they give us 3 consecutive terms and we have to solve. Now, realize I forgot to erase something here. That UN shouldn't be there. Okay, so remember that D is the difference between one term and the previous term. So it's UN plus 1 minus UN. That shouldn't be there. Let me quickly... Does it let me do that? No, okay, never mind. That UN shouldn't be there. Cover it up. Okay, so the difference between the terms, between those two terms, and the difference between those two terms should be the same. So let's try that. This is the difference between the first two terms. So it's the first term minus the second term. No, it's the difference between the second term minus the first term. So this subtract this. Now, just be careful with your signs here. When you multiply out, this is minus k plus 1. Negative terms are negative. That gives us d equals k plus 4. Then we go through the same process. So we find the difference between the second two terms. So this term subtract this term. Again, being careful with our signs. And that gives us that d is 10 minus 3k. Now, because it's an arithmetic sequence, those d's should be the same all the way through. So that d is equal to that d, which means that is equal to that. I've run out of space, but if you solve that, you should get k equals 0. All right, 2 more. So here they're asking us to find the sum of the first 20 terms in this sequence. Always start with what you know. U1 is 110, d is negative 3, n is 20. So the sum, this is the formula for the sum, and then I've just substituted the numbers in. Check that you get 1630. All right, and then the last one, find the sum of these terms in an arithmetic sequence. So 40, 37.5, 35, all the way up to 15. So let's start with what we know. We know U1 is 40. We know D is negative 2.5. And we know we're going to have to use the sum formula, which requires n. We don't have n at the moment. We don't know what term this is. So there are 2 ways to find out what term this is. We can either use this formula and solve for n, or we can, so make that equal to 15. Or we can use the GDC, so we can type this into y equals. And if you look down the table, you will see that the 11th term is 15. So n is 11. Once you've got those ingredients, easy enough to type it into your calculator. Whew, right, that was geometric sequences. That was arithmetic sequences. Let's now do geometric. All right, so again with show that, you need to make sure that you show or repeat the repeated steps. So in the previous example, we were looking for the differences. This time we're looking for the ratio. So it's that term divided by the previous term. In each case, we get a half. You can leave it as a half or a 0.5. They ask us to find UN. So list what you know and put it in the formula. And we get this. Okay. I'm actually going to skip on from here to here because those 2 questions link together, and we'll come back to this one in a moment. So here we found a formula for UN, and they say we'll use that to find U15. Substitute the n with a 15 and solve. Moving on here, it says which is the first term of this sequence which is less than 1. We have a formula for this sequence. We worked it out here. There. So we can type y equals, there we go. And if we scroll down the table, we'll find that u8 is above 1 and u9 is below 1. So u9 is the first term that is less than 1. Very important though, do list u8 as well to show that the one before wasn't low enough. Okay, so list both of them. Right. Okay, let's go back to this one here. So again, they're giving us two different terms and they're saying find un. Now, in the previous example, we substituted what we knew using this one term and what we substituted using the other term, and then we subtracted. Let's just rewind a little bit. We subtracted here to get rid of the u1s. For a geometric series, you need to divide, because if you divide this result by this result, that should equal this result divided by this result. And what happens there is that the u's cancel out, so they disappear. And we're left with 16 equals r to the 4. Find the fourth root using your GDC and we get r is 2. Again, I've run out of space, but once you've found r, you can substitute r into here. That helps you find u1, and once you've got u1, you can build your formula. Wow, we're nearly done. Consecutive terms. So here you've got consecutive terms. Find k. Again, in the previous example, scrolling up, we were looking at the difference between one term and the next. Here we're looking at the ratio, the division. So we're saying this divided by this should be the same as this divided by this. Okay? So using the first two terms, k plus 8 divided by k, using the second two terms, 9k divided by k plus 8. If this sequence is geometric, then that divided by that should be equal to that divided by that. Those ratios should be the same. I've set them to be equal, cross multiply, multiply out the brackets, get everything on the left on one side, make it equal to 0, and then use polysmalt. Finally, sum of the geometric sequences. We've got u1, we've got r, we've got n, which is 20. Plug it in, should get an answer of 40. And here, we've got all the ingredients, but we don't have n. So we need to find n, and in order to find n, we type what we know, which is a formula for un, into the GDC. Scroll down, and you'll find that the 8th term is 4,374. So now we've got all our ingredients, we can sum. Thank you very much for listening.